Hello. Hello, good evening, guys. Good evening. Yeah, wisdom. I see you. I see you. I see you, wisdom. All right. I see you all. I see you. I see you. I see you. Okay, so the first thing I'm going to do is to share this link to as many that don't know we are live. All right. Welcome, guys. Um, Diamond. Welcome. 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 So what I'm trying to do right now is to invite the rest and say we are live. All right, see you all. I see you. Godi presents Informa. I see you. All right. Now, if you are just coming, okay, Amaka, I see you. If you are just coming to this page or this channel, please hit that subscription bell. Ladies and gentlemen, hit that subscription bell. That's the only price you pay for being a member of Jairus Academy. All right, so more persons are still joining us. Okay, so ladies and gentlemen, okay, Mirape, you're welcome. Buddy Joel, Faith, Justina, Gabriel, you're welcome. All right. Guys, if you can hear me, please comment. I can hear you. If you can hear you, if you can hear me, please comment. I can hear you. To be sure that I'm not talking to myself. Okay, Happiness said I can hear you. Informer said I can hear you. Okay, I'm glad. So let's dive into the course. No, so like I said, we have different method of separation techniques. We have the magnetization, we have the filter method, the decantation, we have evaporation, centrifugation, chromatography, distillation. So first, we are going to start with what is separation techniques. That's the first definition. Now, recall that when elements and element comes together, it forms a compound. Are we together? When element and element comes together, it forms a compound. And when elements mixed with compound plus other particles like dust, they form a mixture. Now, what is now the difference between a mixture and a compound? A mixture has a chemical formula. Sorry, a compound has a chemical formula. A mixture does not have a chemical formula. So I repeat. So I repeat. Recall that element plus element gives us compound, right? Element plus compound on other particles like dust give us a mixture. So what is the difference between a mixture and a compound? Now, a compound has a chemical formula, a mixture does not have a chemical formula. Did you get that explanation, please? Please, if you got that explanation, let me know, let me know. Quickly, quickly, quickly. If you got that explanation, please let me know. Okay. Blissful Bliss says he got that explanation. Okay, so let's proceed. Yeah, thank you. Now, note a compound has a chemical formula, just like if we have sodium and chlorine coming together to form sodium chloride. Sodium chloride is a compound and it has a chemical formula which is NaCl, right? But let's assume, for example, now we have oxygen. Oxygen is an element, is a gas reacting with nitrogen plus dust. It's going to give us air. Our air that we breathe in contains oxygen, contains dust, contains nitrogen and other elements, right? So the mixture of these elements and other particles makes it unable to have a chemical what formula. Now, I started by asking what is separation techniques, and I said that note the difference between compounds and elements. Compound is result as is a result of the combination of elements to form the compound, of course, and it has a chemical formula. Then element, sorry, a mixture is as a result of elements and compound and other different particles coming together to form the mixture, and the implication is that it doesn't have a chemical what formula. So moving forward, what is now these separation techniques that we are trying to define? Separation techniques is simply the method that we use to separate individual constituents of a mixture or compound. So for example now, we have oxygen plus nitrogen plus dust to give us air. Now, If we are trying to separate oxygen from air, we will apply a separating what technique. So separating technique is just like the method that we apply to remove a particular particles or element in a combination of the whole what entire what element. Like my slide defined that separation techniques is simply the method used to separate individual constituents of a mixture or compound. So for example, we have a mixture of salt and water. Now, how do we remove salt from water? If we have a mixture of salt and water, you turn salt for inside water, how do you remove it? Or how do you separate the water from the salt? Or the salt from the water? How can you do this? Now, this will now lead us to our first separation techniques. And that first separation techniques, we'll look at the evaporation technique. Now, to be sure that you guys are still following, please type following. I'm following. If you are still following, say I'm following. If you are lost, say I'm lost. If you are still following, say I'm following. If you are lost, tell me you are lost. If you are lost, tell me you are lost. Okay, please said I'm following. Okay, Donatus, I'm following. Tracy, I'm following. Okay, Gospel said I'm lost. Okay, Ogene Fega said I'm lost. Uh, is it Tamarathon said I'm lost? Okay, I'm going to try to explain again. Now, remember I said that. Okay, remember I said that um when element combines with element, it forms a compound. And when elements combine with compound with other particles, it forms a mixture. So what is the difference between a compound and a mixture? Remember, all of them are formed as a result of combinations of other elements and other things, right? So I'm saying that a compound has a chemical formula and a mixture does not have a chemical formula. So example of a compound is sodium chloride. Now we have sodium is an element and chlorine an element coming together to form sodium chloride. So this combination of two elements ends up forming a compound that has a chemical formula. So what about mixture? We have oxygen, we have nitrogen, we have dust coming together to form one thing, which is air. Air does not have a chemical formula, right? Because of the complexity of the things that are coming together, complex combination to form the what? The mixture. So moving forward, and I said separation techniques or separating techniques is a method that we apply to separate the individual constituents of a mixture. For example, now, if I have oxygen plus nitrogen, you can see my slide. If I have oxygen plus nitrogen plus dust, right, to give us air, if I want to separate oxygen from air, I will apply a method that will assist me to separate this oxygen from the air. You guys understand? So, and I said this method that we apply to separate it, the art of removing air from removing oxygen from air is what is known as separation techniques. The method we apply to remove the oxygen from air is known as what separation what techniques. Now moving forward, and I said that if we have a mixture of salt and water, right? There is a salt in the water that makes it salty. What do we do to separate the salt from the water or the water from the salt? So the first thing we can think of is what we call separation techniques. And the first separation techniques we are going to look at is evaporation technique. So if you get this now, please comment, I am following. If we are stick together, please comment, I am following. Please comment, I am following. Please comment, I'm following. If we are still on the same page, please comment, I am following. No comment yet. Okay. Okay. So Alex and the rest, black is beauty. Hope you guys are following now. Okay, X successful. Okay. So let's move forward. I'm glad. So now the first techniques we're going to look at is the evaporation technique. Now, evaporation techniques, like I said, if we have a salty water, that means there's a salt in the water, or the water contains salt. How do we separate these individual constituents? How do we separate the salt from the water? How do we separate the water from the salt? The first thing I will do, I will put it in a kettle. Right? You can see the kettle, and I will boil it. I will heat it. Now, as you are eating it, you can see that there are fumes coming out. This fumes is gas, and I can put a cover of pots or anything to cover these fumes. So immediately this gas hits this cover or barrier or barricade, you see that it begins to form droplet of water. Now this droplet of water is known as pure water. If you taste it, you will discover that there's no saltiness anymore. There's no salty taste anymore. It is pure water. Now, what now happens to the salt? The salt will be left in the kettle. After you heat it to dryness, the dry salt will be remaining in the base of the kettle. So these techniques, whereby we put the salt water in the kettle and we heat it to dryness, is known as what? Evaporation what? Technique. Is known as what? Evaporation technique. Guys, is known as what? Guys, is known as what? Please comment. Is known as what? I'm waiting. Is known as evaporation techniques. Now, moving forward, here's a quick question for you guys. All right, here's a quick question for you guys. Watch your screen. Watch your screen, guys. They said evaporation techniques is used to recover a solid solute from a solution. Now, if you are a nursing student, PTS class, this question is for you. And if you are a Jambai, this question is for you. And if you are WAEC, this question is for you. They say sodium chloride may be obtained from brine. Now, what is brine? Brine is salty water. All right. The mixture of salt and water gives you brine. So brine means salty water. Don't allow it to confuse when you see it in exam condition. So the question says the mixture of sodium chloride may be obtained from, okay, sodium chloride may be obtained from brine by dash. A. Titration. B. Decantation. C. Distillation. D. Evaporation. Please, I want to see your answer. What is the answer? Just comment. Is it A? Is it B? Is it C? Is it D? SC Ogene root. I see you. So what's the answer, guys? Kingsley, I see you. Okay, Gospel says it's D. Successful said is decant. Is it decantation? Successful. Okay, wisdom D. Faith says D. Ladies and gentlemen, anytime you hear the word brine, anytime you see brine, know that brine is a salty water, is a mixture of sodium and what? Chloride. And therefore, the answer is evaporation. D. That's nice, guys. So let's move forward. Now, remember, let me add my face. Okay, my room is a bit dark. All right. Now, remember that we have three states of matter, or matter exists in three states. Sorry, matter exists in three states. So matter exists as a solid, you can see. Matter exists as a liquid, and matter exists as a gas. You can see we can put this in a triangle. I repeat, matter exists as solid, matter exists as liquid, and matter what exists as gas. Now, whenever a liquid is turning into a solid, is known as freezing or solidification. I repeat, whenever a liquid is turning into a solid, is either known as freezing or solidification. Now, when solid is turning to liquid, when solid is turning to liquid, is known as melting. Is known as melting. Now, when liquid is turning to gas, when liquid is changing to gas, is known as evaporation. You can see the arrow, evaporation. And when gas is turning into liquid, when gas is changing into liquid, is known as condensation. Then when solid is changing into gas without passing the liquid stage, is known as sublimation. So a good example of element or compounds that exist, or a good example of sublimation, is your camphor. So camphor, for example, disappear into the thin air. That's sublimation without passing through the liquid phase. Ladies and gentlemen, matter exists in three states, and these three states can change, right? Solid can change to gas, gas can change to liquid, liquid can change to solid, liquid can change to gas. They always what? Changes. All right. So anytime they are changing from one state or from one phase to another, you have to know the names, and these are the names I just brought out. So we have freezing, melting, sublimation, evaporation, and condensation. Now moving forward, this is another question for the nursing students, jam bites, why questions as well. Now, the movement of liquid molecule from the surface of a okay, sorry, okay, yeah, the movement of liquid molecules from the surface of the liquid to the gaseous phase is known as dash. So the question is saying, when liquid changes to gas, what is the name? Please comment. Comment. When liquid changes to gas, what is the name? What is the name? When liquid changes to gas, what is the name? Okay. Precious. Okay, lost in precious. C. and C is the correct answer. Okay, I love that. So let's now proceed. Second question: when solid substance disappear completely as a gas on heating, the substance is said to be that. That is, solid is changing. Solid is changing to a gas right now. The question is now asking: is it sublimation? Is it crystallization? Is it distillation? Is it evaporation? Please comment your answer. We just said this. Okay, Lost in Precious says, Lost in Precious, are you a nursing student or a jamba? Okay, Bliss says it's A. Harvest says it's A. Favor Shisom says it's A. Donatus says it's D. Ladies and gentlemen, the answer is A. So we said that um, when a solid changes to when a solid changes to um, gaseous state without passing the liquid state, it is what? Sublimation. Now moving forward, the next thing we'll talk about is filtration. The next type of techniques, or the second techniques we talk about, separating techniques we talk about, is filtration. Now, ladies and gentlemen, filtration or sieving. Now, for example, if I have stone and water, I want to separate stone and water. What do? I simply what? Filter out the water and remove what? The stone. That thing I just said is filtration. So, a separation technique that removes solid particles from a liquid or gas by passing the mixture through a filter is known as filtration. So we have stone and water. I can filter out the water, leaving the stone behind, right? Now, sieving is a bit different from filtration. Sieving is the art of separating particles of different sizes by passing them through a sieve. For example, now Gary. Now you've seen where they sieve Gary, because Gary has some, after processing, Gary has some bigger particles and smaller particles. So they try to filter it, and the bigger ones remain on top while the smaller particles goes down. So when you separate these particles based on their different sizes, what you are doing is what? Sieving. What you are doing is sieving. All right, so let's look at this. This is a good question. Oh yeah, let's attempt it. PTS Jambites Y question. Sieving is a technique used to separate mixture containing solid particles. A. Small sizes. B. Large sizes. D. Different sizes. Then C. Different sizes. Then D. Same sizes. Okay, Glory, I'm glad that you guys are following. That means I'm teaching good tonight. All right, I'm glad that you guys are following. Okay, so the answer is indeed C. We use sieving to separate particles of different sizes. Nice one, guys. Nice one, nice one, nice one. So that means we can move forward. Now, the next type of separation technique we'll look at is separating phoneme. Ladies and gentlemen, separating phoneme is used to separate two immiscible liquid. For example, if I have oil and water can never mix. If there's a mixture of oil and water, one must be floating, right? And which of them will float? Is the oil that will float. Why will the oil float? Is because the oil is lighter than the water. So separating funnel is used to separate two immiscible liquids, right? Such as oil and water based on their different density. Density means heaviness. So the question now says, among oil and water, which one do you think is heavy? Of course, water is heavy, oil is what? Light. That is why. Hello. Can you guys hear me? Hello. Please, can you guys hear me now? Uh, I'm back. I'm back, guys. I'm sorry. I'm sorry. So, like I was explaining, the second thing or the third type of techniques we look at is the separation funnel. So if we look at this separation funnel, we said or separating funnel is used to separate two immiscible. When we say immiscible, they cannot miss. All right, they cannot miss. So example, we have the oil and the red oil and water. In fact, all oils and water. Now, why can't they miss? Why can't they miss? It's because of density. One is heavier, it's too mixture. You simply put it in a funnel, right? That has a cork, and you allow it to settle. You can give it 1 hour, you can give it 30 minutes to settle. Now, when it settles, you see the oil will be floating, and the heavier one, which is the water, will be down. So just open the cork a little, and you see the water is going to rush out. Once it rush out, leaving the oil. So once the oil is about to come out, you quickly lock it. Now, ladies and gentlemen, you successfully separate water from oil based on their density, based on their different what density. So you use separating funnel to separate immiscible what liquids. Now, to ensure that you guys understood this, please comment. Let me know. Let me know. Please, the mic is working now. Please, the mic is working now. Are we together? Yeah, yeah, I've done that. I've done that. Okay, so let's look at this question. There are two questions. So we have number one, number two. So the first one says, which of the following mixture can be separated using a separating funnel? Please answer using a separation funnel or a separating funnel. Please answer using a separation funnel.